Okay, this is the second part of the second video, and we're going to again manually polarity transition while not being in voltage regulating mode anymore. Now we're going to do current. For that, we've actually done it backwards. We've taken the voltage limit all the way to 100%, and now we're going to control through the current limit. And again, all this is done through the potentiometer. We're not using the current command, the external position 12 and the 11. And when we go to external, I'll talk about a couple of jumpers here that have to be modified so that we can come in externally. Right now, those jumpers are installed. So again, we have power, obviously. I know that we have power because I see lights. I know that they have a phase loss clear. We have the 240 from the wall because that phase loss, it's there. So this is the kind of information that you get from what's going on from the LEDs. We're not transitioning, and I know that it's inhibited. We are not on yet because we haven't we haven't enabled the unit that switch between polarity, soft on and off, 4 and 5 of TV1. It's closed. It's on the inhibited position, and there it is. Here we have it. The handle is on this side, or the rocket on this side. That means that these two are closed. Now we're gonna let that go. Go ahead. And again, just like last time, we have the minimum DC output, which corresponds to levels, about 6/10 of a volt. All right. So we have our current feedback. We don't have anything. We have the voltage feedback. That again, it's about 0.007 millivolts. And what does my current clamp say, Tony?
0 right now.
Okay. Yeah. All right. You can just read it out. Yeah. All right. So again, manual. And now we have the power LED, and now we have the current limit, current regulation. All right. Let's start going. And now really, if we wanted to, we would need to look at the current feedback over here. So that's really what we would be controlling. There it is. So what you can do, basically, it's easier to look at the voltage. So let's stop at okay, just go all the way up to an okay on my way. No problem. Okay, it's going to be at about 3 something, 305. Okay, and there it is. So do me a favor, Tony, and start slowly coming back while we look at the oscilloscope. And again, we're on the opposite, on the positive output. And there it is.
Move up.
Yeah, just keep on going, Johnny. No, just keep on going down, Johnny. Yep, so you're going up and down as the clock is going down. And now let's stay at about 75 or 80. No, just keep on coming down.
Go 80.
Okay? Just go a little bit low. That's about right. Okay? So we got 50 volts DC. And now let's pay attention. What does the current say on the current draw? No, clamp?
5.4.
5.4 amps, which will be there's 1.4 for the transition because this is a 200 amp. Every milliamp, it's 4 amps. That way 25 milliamps and 4 is 200 amps. But we only have 1.4 times 4. So that'll be 5.6, I believe, or 5.2 amps. Now let's go ahead and transition on. So there it is. It's and we have 2.2, and we have negative 78. And let's increase that 20 a bit. Let's go to about 150. So that's fine. Okay. There you go. All right. By the way, we got multi-term potentiometers to give you all kind of more than control. It's flexibility of adjustment. So we got 167 on the negative, 4.7 amps. And you notice that I'm not looking at the voltage here, which it shows that it's negative, but the ISO 5 has an absolute value circuit that just takes that positive value. So we have 4.7 and 166. Let's go ahead and show that LED. Go ahead. Alright, now we can see the output. And because we are doing the current regulation, this is trying to stay the same, the 3.6 volts times 4, and we have 125 on the output. Let's go all the way to the full output zone. Okay, so there we are at 305, and we have 8.6, and you have 8.6. What is the current output?
33.2.
33.2 amps. So let's go ahead and transition. All right, see it there. And then we have again the 305 and the 8.5 output. So this is basically doing the same as in the previous video, but now using the control command. Of course, here we're showing the extreme, but at any given time, the customer can set the voltage limit to not to the maximum, but to any desired output, and then use the current limit pot and set it as desired. The board will only be in current or in voltage, depending on only one and one only, depending on what the minimum setting we have. If the current limit is less, it will be in current limit. If the current voltage is less, it will be in current voltage. All right, let's go ahead and inhibit, and this is